growing issue in today's urban life is power scarcity. This is an issue that is only set to grow as urbanization increases. Now, the best way to reduce power scarcity is to use less power. Now, around us there's a lot of places where power is wasted, but one place that people realize least is lighting. Hundreds of megawatt hours of power is wasted each day because of inefficient lighting systems. Lights in office spaces, bathrooms, corridors, lobbies, lifts are generally kept on all the time when nobody is using it. We have developed a solution to solve this problem by firstly making the lights themselves more efficient by using solid state lighting systems, and secondly by making the lights smarter and making them turn themselves off when no one is requiring it. And finally, by building a network of such lights communicating over the power line, we have been able to achieve a network of smart lights that can save power and still provide sufficient lighting. This is our basic light module. We have two LED arrays here, each consisting of 40 LEDs, so we have totally 80 LEDs rated at 0.25 watts. And these LEDs were chosen primarily because they were very economical as well as power efficient, and the brightness they gave was satisfactory. We have two LED drivers here from TI that drive the LEDs. These are TLC 5916 drivers from Texas Instruments. We have a comparator here, an LM358, to take inputs from the PIR sensor. We have another sensor here which is a light dependent resistor for sensing ambient lighting conditions. And at the heart of the system we have an MSP G series 2231 to control the whole thing. The ADC of the MSP is connected to the LDR as well as the comparator's output. TSOB 1738 sensor here is used to communicate with the remote that we have built. We have a passive infrared sensor here to basically detect human motion. This thing changes its voltage levels depending on whether or not a hot body is present in front of it. What this board consists of is a PLC ASK modulating IC, which is a TDA 5051. This is the voltage regulator. There's another MSP here, but that's just for testing purposes. We are not using it with the light module. The TDA IC is connected to an isolation transformer by Murata, which connects to the outside power line. This is basically the circuitry for protection, fuse, and these two wires take us to the power line. This is the basic remote control that we've built. This consists of a capacitive booster pack that we sourced from TI and an IR LED. Under the booster pack actually is an interfacing microcontroller, in this case an MSP G series 2452. As an alternative to this remote, we have also provided an alternative basic remote which uses another G series microcontroller and buttons instead of the capacitive touch to reduce power consumption.
I will be switching on the light with this remote. As you can see, this light is very bright. To demonstrate this, we will be turning off the lights in the room. As you can see, I am currently dimming the light. There are 16 such values that we programmed. This is the maximum brightness. If you try to increase the brightness beyond this value, it will ignore your command. Same as if you try to reduce the value beyond off. This is the ambient light sensing mode. As you can see, it is now currently detecting the ambient light. If I was to cover the sensor, the light increases in brightness. Again, to demonstrate this better, I will be turning on the light of the room. As you can see, the light has gone off. As you can see, this motion detection sensor has been turned on. If it detects no motion in the room, the lights will dim. However, if a person is to walk into the room, the light turns on, and as the person exits, after sufficient time delay. For the demonstration purposes, we've reduced it to a very negligible value, but as you can see, the lights dim. This is the dim state value. If I was to change this value and reduce it to say 0, then once the function is reset and motion is detected, when this light dims once again, it will dim to the value that I have now changed it to. This remote utilizes the CapSense booster pack that we've obtained from TI. This remote has the same functionality as the other remote, but it uses slightly more power. However, it is much easier to use. I shall be demonstrating this now. I will be turning on the light. The light has been turned on. Now I shall be reducing its brightness. As you can see, the brightness is easily reducing, and this simple gesture is able to reduce the brightness of the light. Now I shall be increasing its brightness. By moving my finger clockwise, I am able to increase its brightness. This makes it much easier to use than the switch remote, and it gives a much better feel.
Basically, any light which is connected on the same face as the Ethernet module can be accessed by the Ethernet web page which is hosted on the BizNet IC. Here in this setup, we have the light which is connected to the power line, and on the same power line we have connected another TDA IC which sends signal to the MSP 430F series, which controls the web page on the BizNet IC. On this, we can access the web page on the BizNet IC through a browser in any client which is hosted on a system connected to this network. For example, here it's a laptop. So as you can see, I can read the values of the light. I can change this mode of the light as well, like motion detection, twilight mode. I can also change the brightness level. I will increase the brightness level. Similarly, you can also change the mode the light is in, the mood light brightness, to the LDR value, etc. etc. On this network, we can access other lights as well, which are connected to the same power line network, or we can access all the lights at once. The MSP 430F series keeps a log of all the lights which are connected to this network, and it keeps updating it every 1 minute or so. Now I'll change the mode of the light with the remote. So if I read status, as you see, when I read status, the LDR mode is on.